Okay, so I think it's a good number. So okay, so I'm not talking to myself now. Good afternoon semua. I want to see everyone just for a little while. Show you the screen. That's how it goes for online learning. Tetapi feel free to interrupt my class and feel free to ask me questions during my class. We will cater classification of organic compound based on their functional groups. We will look at resonance concepts. And lastly, we will look into the drawing of chemical structure. And that's the part where I want you all to draw by yourself. All right. So let's jump in okay. So basically, these are the summary that I got from compoundchem.com for functional groups in organic chemistry. Okay. These are the functional groups in organic chemistry overall. That means everything that exists in organic chemistry. Okay. So beginning from the hydrocarbons, so the first one is alkane, and then the last one is actually arene. So let me look at everything first. So we have hydrocarbons, alkane, alkene, and alkyne. These are the things or the functional groups that you all should be familiar at, something that you have looked before, whether you want to remember or you want to delete from your memory, but you have seen this. And then we have alcohol, ether, epoxide. I think ether in epoxide could be the first time that you've seen it. Okay, and haloalkene. And then we have the carbonyl containing groups such as aldehyde, ketone, carboxylic acid, acid anhydride, ester, amide, alkyl halide. So the second row are the ones that you will see in SKO3023 that I will not cater in SKO3023. Okay, and then you will look into amine, nitrile, imine, isocyanide. Actually, isocyanide, we don't always encounter them for functional groups on the basics of chemistry. And then we have azo and thiol. So thiol is basically some sort of alcohol, but you replace oxygen with sulfur atom. And arene meaning anything that begins with benzene, and it could be its derivatives. Now, for SKO3023, we will look into the first row only. We will look into the first row functional groups only. Okay, we will look into the first row functional groups only. Now, to differentiate all this, okay, you will begin with what we call as hydrocarbons. Okay, after we will look at stereochemistry topic, okay, you will see hydrocarbons. Now, what do you mean by hydrocarbons? Basically, any compound that only contain carbon and hydrogen. So any compound that contain carbon and hydrogen. Okay, so we will see, for example, I'll show you two atoms punya compound. For example, you have ethane. Okay, it's two carbon atoms. Okay, so and you know that carbon must have 4 hands, right? So this is ethane. So it belongs to the functional group. Dia apa? Functional groups dia ialah alkene. Now, if I replace the single bond to a double bond, for example, something that looks like that, right? So this is ethene. All right, ethene. So it belongs to the functional groups called alkene. Now, if I replace the single bond to a triple bond, and I observe something like this. So this is ethyne or acetylene, right? Ethyne or acetylene. Something that we have seen before in the hybridization topic. Okay, so it belongs to the functional group of alkyne. Why is it important for you to understand about the differences of functional groups? Very important in this is because if you fail to identify that compound belongs to which functional group, you then fail to name the compound appropriately. Okay, because if you know, okay, the how do you say, the suffix, okay, the prefix, the suffix, okay. Prefix mean pre, meanings the first part of the name is actually saying about what number does that compound has, what number of carbons, all right. And then the suffix, the end part actually representing your functional groups. Okay, so if you fail to distinguish which compounds belong to which functional groups, you then fail to firstly name your compound accordingly. Okay, so make sure you see if it has triple bonds, and it is alkyne, double bonds alkene, single bond alkane. Of course, this is not limited to only, for example, these functional groups only. Later on, okay, you will see that you will learn about what we call as priority. Okay, priority or superiority, meaning if, for example, you have a double bond, at the same time you also have alcohol. Now, which one shall be your suffix? Okay, that later we will learn the topic of alcohol. But first, this for your general understanding, you shall learn about the differences in the functional groups. So basically, on this slide, we will cater hydrocarbons. Now, what's next? After hydrocarbons, you will look into alcohol, ether, epoxide, and haloalkane. The first one that we will look after hydrocarbon compounds, after alkane, alkene, and alkyne, is actually alkyl halide. Is alkyl halide. Now, from the name of alkyl halide, okay, this is another functional group that you will learn. Okay, from the name itself, you know that the compound contain alkyl part. Alkyl meaning alkane that now becomes derivatives. Alkane that alkane, alkyl is substituent. Sorry, so it contains the alkane part as well as the halide part. So if you see halide, you know halide meanings it contains halogen atoms. Now, halogen atoms in the topic of organic chemistry, SKO3023, I think, for SKO3013 or 3033, the halogen atom that we always find is either bromine, chlorine. Okay, those are the most significant one, I say, bromine and chlorine. Seldom, okay, very rarely we will see iodine, for example, or astatine for the fact, okay. But for the purpose of naming, yeah, you will see fluorine, you will see iodine, for example. But for the purpose of reaction, no. It always be bromine or chlorine because they are the yeah, intermediate ones or the middle ones. Okay, so they are not too reactive and they are not too passive. Okay, now the important thing also for you to be able to distinguish functional groups, in addition to naming, in addition to IUPAC naming, also the reaction and synthesis. Now, if you fail to identify, okay, yang ini which functional group does it belong to? Of course, you cannot determine then what will be the subsequent reaction yang akan berlaku to that functional group, or how are you going to prepare that compound. Okay, because after this, when we will look into exactly, we will talk about the details in the functional groups, there will be a lot of reaction and synthesis corresponding to that exact functional group. Okay, now, of course, organic chemistry is interrelated topic. Sometimes you will see synthesis of alkyl halide, but it is also the reaction of alkane. Okay, now, alkyl halide, from the name itself, you know it is containing alkyl and alkyl halide. Now, if I go back to my example of carbon compounds with a compound alkyl halide with 2 carbon, so I'll show you something like this. Okay, now 4 hands, carbon must always have 4 hands. But if I replace that one atom to a chlorine, now this functional group does not belong to alkane. but it is alkyl halide. Now, later we will learn about the naming. How are you going to learn? How are you going to name the compound? Basically, in the priority or in the hierarchy of the functional group, halogen or alkyl halide is lower than alkane. So for IUPAC naming, later we will recap this, okay? But for the purpose of distinguishing, I'll show you this. Now, for the purpose of IUPAC naming, this will you will say this as chloroethane, okay? It doesn't this one you don't need to do the numbering because either side it will be one, okay? So this is chloroethane. But for what you call as common name, you can use, or you can call this as ethyl chloride. Now, if I say name the compound, either names will be good, either name will be correct. But if I say IUPAC naming, then you have to prioritize your alkane, because in the priority, in the hierarchy, alkyl halide sits lower than alkane. Now, we have looked at all the hydrocarbons, we have looked at alkyl halide. Now, SKO3023 will also cater this part: alcohol, ether, and epoxide. Actually, ether and epoxide will be the last topic that you will see in SKO3023. Okay? So, if I'm not mistaken, I think that's about it for SKO3023. Yeah. Okay? So now, later, after alkyl halide, you will look at alcohol. Now, alcohol is, now we are going to introduce another atom, oxygen, as your main component. Okay, so if I go back to my example of carbon with two compounds, okay, so you have carbon, same thing, okay, but now instead of replacing that hydrogen with a chlorine, I will now replace them with what we call as hydroxy group. Okay, so alcohol. So now this one is no longer alkane nor alkyl halide, but it is alcohol. Okay, so how do you name them? For very simply, IUPAC naming will be ethanol. See, because it is alcohol, this part is now different. That part is now different. But the first part, if you see here, ethane, at, you know, so everything on the prefix of the name, the first part of the naming is the same. Why? Because it has two carbons. Everything has two carbons. You see, alcohol. Okay, so if you want to distinguish now, it's very easy because you know hydrocarbons basically is just interchanging or changing the double bond or triple bonds. Alkyl halide, if you see additional halogen atom, then it is alkyl halide. Okay, if you see now alcohol, if you see oxygen, okay, there will be two type of functional groups that you will see containing oxygen, which will be alcohol, also ether. Okay, but the differences is for ether, oxygen is sitting in the middle. Okay, likewise for epoxide. Now, if for example you have everything, for example, you have everything, you have alcohol, you have double bond, you have alkyl halide in your compound. For example, let me end show and keep my inks, and I'll okay. For example, I have okay. For example, something that looks like this. Okay. Now, we are not learning about the naming yet, but for the purpose of distinguishing, so you will see. For example, I have double bond there. Now, okay, this could be my ridiculous compound, but you will see it's not that ridiculous. But later, you will learn about how to name this complicated structure. Okay, it's not that complicated really. Okay, so you see, okay, walaupun kita belum belajar the IUPAC naming, we haven't learned about IUPAC naming. Now, for this purpose of the talking about this, now we have everything, but ether and epoxide. We have alcohol in the structure, yes. We have double bond in the structure, yes. We have chlorine or halogen atom in the structure. Now, because of the priority or the hierarchy, this compound suffix, the N1, the functional group, the highest functional group that exists here is alcohol. Now, how are you going to name the compounds? Now, I think although we are going to cater this later, let me just give a general perspective about IUPAC naming. Okay. Now, if later we will learn about this, but for the purpose of this class, I'll tell you. So the first one, you'll see I say this will be our main functional group. So you're going to take this part as your parent chain. So everything here until here. So basically you have carbon 1, carbon 2, carbon 3, and carbon 4. Okay, so you have 4. 4 carbon meaning what? But, right? 4 carbons meaning but. So second one is functional group is what? Alcohol. So dia ada all di belakang. Right? Now where is our alcohol? Alcohol is sitting at 1 all. Sitting at carbon 1. Now, because now it has the double bond. So you have to tell me where is the double bond. Double bond is at carbon 2. Okay, ni sambung So after this one, we're going to look at here. Okay, so after we determine what functional groups, we see what other substituents that exist. So the first one is a double bond. So a double bond is located at carbon 2. Now, halogen, we now also have halogen. So this halogen is a chloro. Where is the chloro located? At carbon 4. Okay, don't worry, we will look at this again when we have reached the topic of alkane later. Okay, but for the purpose of discussion, I'll show you this. You will learn about this whether you want it or not, right? So then we have everything now. We are going to combine what we have, right? So we will put your, of course, in shall be in the middle. You cannot say in before chloro. So the compound name will be 4-chloro, 2-in, okay, but. Okay, so let me erase this one. Okay, 2-in but 1-all. Butan 1-all or 1-butanol. 2-in 1-butanol or butan 1-all. So anyone has respond on this? Okay, so walaupun baru memperkenalkan functional group, okay, tetapi saya saja nak memperkenalkan ini juga supaya you all are aware of this. Okay, alright. So I'll keep this slide. Okay, so now for ether and epoxide, basically the difference between alcohol and ether is that ether now has alkyl and alkyl. R, okay, if you see R there, this one, R is alkyl. Okay, so a couple of things before I forgot. X is for halogen atom. R is for alkyl group. Alkyl meaning the chain. If you relate to the alkane, so it will be now alkyl because it has become substituent. So difference between alcohol and ether is that for ether, oxygen is in the middle. So epoxide is quite different as well because epoxide now, the oxygen is no longer in the middle, but the oxygen is now pointing up, right? That, okay? So you have epoxide looking like that, okay? Where oxygen is now there. Don't worry, just distinguish them and then we'll be okay. So the importance of functional groups: name, synthesis reaction. Okay, and of course, the property will be different. For example, the boiling points of alcohol will definitely be higher than alkane, butanol and butane, so those things. Okay, now we will look into the very first topic of SKO3023. Not very first, but for this, for this chapter. All right, it is resonance. Now, if you want to read this, is that some molecules are having structures that cannot be shown with single representation. They are compared using the following criteria. So in resonance form, only the electrons move. Okay, so they are compared, meaning you will then learn about which resonant form is major and which one is minor. Okay, basically you will distinguish them using these criteria. Okay, whether the resonance form, okay, this is form, resonance form, not compound here. It has as many octet, has many bonds, has a negative charge of the most electronegative atom, and has a little charge separation as possible. Now, today, in addition to finishing up our lecture, at the same time, saya dah prepare an exercise sheet yang kita akan buat waktu kelas. Okay, so that you will see, bolehlah dig through atau benda you tak faham. Okay, so the real structure is a hybrid of different resonance form. For example, nanti after this we will look into benzene. So arrows connecting resonance form are double-headed. Okay, for resonance, sekejap. For resonance, you will look at these three main important things. The first one is this. Where is it? The first one is this symbol. Okay, is that equilibrium or is that resonance? Oh no, that's equilibrium. Sorry. So you will learn about three symbols. The first one is that meaning that resonance form to one another. You will also learn about arrow, movings of arrow. Okay. So those arrow are showing the movements of electrons. In addition to that, you will also learn about charges, positive and negative charge. So positive meaning that atom is now transferring its electron. Positive meanings donate, negative meanings accept. Okay, so the most common one will be benzene. So this is benzene. Benzene is a cyclohexane looking structure, but it has 3 double bonds. So because of the 3 double bonds, okay, now, for example, if you have alkene, there will not be any resonance form. Resonance will only be possible if you have what we call as pi bond. Pi bonds is double bond, or the electrons that can be moved. Okay, because sigma bond, for example, dalam double bond punya structure, it has 1 sigma and 1 pi. In the triple bond punya structure, alkyne, it has 1 sigma, 2 pi's. Meaning the pi electron is the one that you can move around. For example, if I have cyclohexane, there will not be any possible resonance. Okay, so this is resonance representation. Now, okay, I'll show you benzene. Okay, so you see now this is what we call as benzene. It has 6 carbon, hydrogen 6 sahaja. Okay, you will see alternating double and single bond. So let me show you benzene structure. So I have 1, 2, and 3 double bonds. Okay, so these double bonds, because they are double bonds, of course you can move the electrons. So for example, you are moving this electron to there. Okay, because this is benzene, so it moves a lot. Later I'll show you an example where you will stop the movement of electron. Okay, for the purpose of benzene, because it is revolving. It moves a lot. So you cannot simply say, okay, because we are donating this electron to there, now this is positively charged. It doesn't work for benzene, because benzene, you have to keep rotating its electron. So now these pair of electrons have been moved. Because they've been moved, you will show you the arrow. So that arrow is showing a resonance form, right? So the resonance form of that benzene now shall be the double bond is shifted there, this double bond is shifted there, and that one is shifted there. So you can then also, these can be later moved again, right? You can move again and you will get the first structure. Okay, you will get your first structure. Because of this, then electrons will keep moving. Because of this, then benzene can be simply represented as that, meaning the electrons are moving. Okay, electrons are moving. So electrons are all there. Because electrons keep on moving, so you can simply draw benzene as circle in the middle. But is it wrong to show benzene as triple bond? No, it is not wrong. Again, if you look at the resonance punya topic, is that dia ialah cannot be shown with a single representation. Okay? Now, the arrows and the positive negative charge not only important for resonance. The movement of electron not only important for resonance. Later, untuk SKO3023, you will also learn about mechanism. Alright? So mechanism also involve a lot of movements between electrons, okay, and bonds, and consequence to that, you will observe charges, right? Okay, so this is an example of major and minor contributors. Now, this is an aldehyde, okay, formaldehyde, where aldehyde is another functional group that we will not talk about it in this course, but of course, resonance, yeah, you have seen an example. Between carbon and oxygen, you see this example there? Between carbon and oxygen, carbon is more electropositive and oxygen is more electronegative. Jadi oxygen is more prone to accept electron. Okay, because of these properties, So because of that, the double bond, okay, can be moved towards oxygen. This is something that I mentioned last week. One bond is equivalent to a pair of electron, meaning 2 electron. One bond equivalent to 2 electrons. Okay, bila you dah gerakkan, when you have transferred, so this one it has been transferred. The bond has been transferred there. So you observe a new electrons. Okay, consequence to that, you will observe the charges. Okay, because dia dah donate, maksudnya dia ada positive charge. Dia dah accept, so it has to be negative charge. Couple of things can go wrong here. First, if it doesn't show movement of electrons, it will be not correct. Second, if there's no transfer of electron, maksudnya you pindahkan je bond, tapi you tak tunjuk ada additional electron pada oksigen, dan yang itu juga adalah tidak betul. Selain daripada tu, in addition to that, if you fail to show me you punya charges, then it will also be not correct. Okay, it will also be incorrect. Kalau you tak tunjuk mana positif, mana negatif, atau you tersalah, okay, that will be not right as well. Okay. So the major contributor in this case is where it all contain complete octet of electron. You see, that one will be your major contributor because it has all octet. Selain daripada itu, okay, when both resonance forms obey octet, okay, but so the major resonance is the one with the negative charge on the most electronegative atom. So we have cathode. First one, okay, yang major mesti ada as many octet as possible. Second one, it has as many bonds as possible. Also, it has negative charge on the most electronegative atom. So in this case, for example, you know, major one, oxygen is more electronegative in comparison to nitrogen. Because of this, then this structure will be your major contributor. Okay, so these forms, macam mana dia boleh jadi macam ni. Okay, so basically, if I want to show you this, so you have that carbon, that oxygen, the two negative, and then you have like that. So the first one, so this is basically moving. So let me draw macam lagi pekat sikit kan. So basically you are moving that electron there. Okay, you are moving that electron there, and you because kalau you movekan yang daripada oksigen punya 2 elektron tu ke carbon tu, nanti carbon ni ada 5 tangan. Bila carbon ada 5 tangan tak boleh. Carbon mesti hanya ada 4 tangan. Kalau carbon ada 5 tangan, mungkin you nak letak negatif kat carbon, but you know carbon tak boleh negatif. Okay, carbon dia adalah prone untuk jadi positif. Because of that, then electrons will keep on moving. You will then move this one bond to nitrogen. Because of this, then you will observe nitrogen to have 2 pair of electrons with a negative charge. Okay, and then this carbon dah stable. Alright, and do you need to put positive pula pada oxygen? Tak. Okay, remember this. The flow goes like this. Neutral, kalau dia donate positif, kalau dia ada lebih negatif. Nah, kalau dah lebih, dia buang. Contohnya you ada RM15. Okay, and then you only need RM10. Okay, so if you donate RM5, because you only need 10, right? So you punya pocket tak jadi negatif lah. So it will be neutral. Okay, now because negatif, nampak tak oksigen yang negatif dia ada lebih elektron. Bila dia dah donate, dia dah jadi neutral. So you don't need to put tiba-tiba sebab dia negatif, lepas tu dia donate, dia jadi positif. Tak negatif, donate, dia jadi positif lah. Tapi kalau positif donate, kalau negatif donate, dia jadi neutral. Tapi kalau neutral donate, dia jadi positif. Okay, so and you can also observe non-equivalent resonance. So the most stable ones is with the smallest separation of positively charged atom. Okay, kalau you tengok ni, dua-dua ada oksigen dan oksigen. Okay, dan juga semua octet. Tapi kalau you tengok ni, opposite charges should be on adjacent atom. This is just an example. So we go to the problem. Okay, so draw important resonance form for that structure. SCH3, oxygen in the middle, and you have CH2 with a positively charged carbon. Okay, indicate which structure is a major and minor contributor, or whether they would have the same energy. Now, for this one, you terus sahaja draw dia punya detail structure. Draw its detail structure. Okay, now oxygen, you have extra oxygen there. You can move the oxygen to the one with less electrons, that will be positively charged carbon, and you will observe oxygen as positive. Now that one will be your major contributor, because the first structure, okay, the minor one has a carbon with only 6 electrons around it, but the major structure has octet on all the atoms and additional bond. Okay, so that is resonance. Don't worry, later kita akan tengok the exercise yang saya nak show kepada you guys. Okay, siapa yang datang kelas je boleh dapat exercise ni. Okay, so this exercise sebenarnya nak replace more, bukan replace lah, as an additional thing for your 1 hour tu. Okay, now solve problems. So dia kata draw resonance structures of the compound below. It's been given. The structure is given. So indicate which structure is the major one and which one is a minor one, or whether they would have the same energy. So you see, walaupun dia tak draw 2 pair of electrons there are actually electrons surrounding your oxygen. Okay, now because it is extra, so kalau I nak start from kalau you tengok kat sini, dia dah terus tunjuk macam ni kan. Tapi kalau you want to start earlier, you can see, okay, this one has electrons there. So hydrogen, and you have carbon, okay. You have oxygen like that, okay, and then you have hydrogen. walaupun dia tak berapa stabil, tapi you can move this one first. You can move this electron first. You can move that bond, okay? And then you will, okay, let me draw a prettier structure. So I have, kejap okay, hydrogen. Okay, let me add a slide. Okay, it's 1140 talking about resonance alone. Okay, so this structure C oksigen. Ada yang pelajar kata, doktor, tak apa ke kalau tiba-tiba saya nak buat dia sengit? Tak apa ke kalau dia tiba-tiba tegak? Tak ada masalah. Okay, untuk organic chemistry ni tak kisah tiba-tiba you nak lukis. Kalau alkane semua orang lukis macam ni kan. Tiba-tiba you kata, doktor saya tak nampak lah lukis macam melintang. I have to draw it horizontally. Oh sorry, what do you call this? Menegak. Tak ada masalah. Okay, untuk carbon, untuk organic chemistry doesn't matter. You nak sengit ke, you nak tegak ke, tak ada masalah. Okay, hydrogen. And then this one ada hydrogen. And then you have negative kat sini. So even though okay, so I'll show and I'll use the difference. Okay, even though it's not really stable, but I'll show you this sebab kita tak boleh ada tiba-tiba kita ada dua atom yang bercharge negatif, tak boleh. Dia kena ada satu negatif, satu positif, that's it. Tapi untuk you punya understanding, macam tadi kan, kenapa you kata tiba-tiba je dia dah jadi move electron macam tu? Okay, why is it like that? So let me show you. In this compound, what you see is that you have a more electronegative atom there in oxygen, right? So more or less you can move this bond to the oxygen and you will observe, okay, walaupun tak berapa stabil, walaupun it's not that stable, but now you have, okay, remember that pair one bond dah jadi a pair of electron, one bond dah jadi dua elektron. So kat sini dia kena charge negative, dan di sini it's now positive sebab you dah donate. Walaupun ini is the most unstable structure because now you have two atom dah negatif. Tak boleh dua atom negatif. Because of this now, the neighboring carbon has more electrons. So what you do? You donate lah. Okay, I'll use a different ni so that you see the differences. Okay, so let me use a green one. So you can move this electron here. Okay, so you observe the next resonance form, which double bond there. But now this positively charged carbon is no longer positive, and that negatively charged carbon is no longer negative. Right? So you have that hydrogen. See? Boleh tak? So you dapatlah the structure yang kedua ni. Kan? Dapatlah structure yang kedua. Setakat ni ada soalan tak? Setakat ni ada soalan?
Tak ada.
Alright. So kita move So this is another example where you have extra electrons on nitrogen. Not extra lah. It's just enough. But you have deficit of electron, kekurangan elektron pada carbon because it is positively charged. What you can do is you can move that pair of electron becoming a single bond, and the positive now has become neutral. Okay, so everything here is in your notes. So this is another example using acetate, where in addition to you observe a double bond next to oxygen, you will also there's also a lone pair of electrons in another oxygen. So there are two oxygens in this case. So you see that it has now become acetate. So acetate dah jadi negatively charged oxygen kat situ. So you can move that oxygen, so the pair of electron to the single bond between carbon, and you can further move your bonds. All right. And then now we have reached the topic of chemical structure. Tadi resonance dah done. Saya akan tunjuk sekejap lagi exercise untuk resonance untuk hybrid. Okay. Okay, so now chemical structure pula. So these are example of chemical formula. Selain daripada ni, you also have learned about Lewis structure. Okay. So empirical formula, something that you actually have learned in SKU 3013, where it is the smallest ratio in a molecule, or simplest ratio of atoms in a molecule. Also have molecular formula. Essentially, for organic chemistry, we will focus on molecular formula, because there's no need for us to empirically show you the formula, because if we show you empirically, meaning, for example, you have C2H6, but now you are representing as CH3s, so that doesn't exist in organic chemistry, because organic chemistry is detailed, so everything shall be represented carefully, so it will be always in molecular formula type. Okay. Kecuali we are simplifying it, as for example ethene, but you show something like this. All right. So that exists in organic chemistry. Okay. So dia dalam terangkul dalam satu kurungan. You have represent repetitive units of CH2, for example, so you show that, for example, you have CH3, and then you have CH2 three times, and then CH3. So essentially this is what? You have one carbon, 3, 4, 5. So this is essentially pentane. Okay, pentane. Alright. So in organic chemistry that exists. Next one is structural formula. Structural formula is everything is it's showing carbon, which hydrogen belongs to which carbon. Okay, it's the very detailed structure. Sometimes people call structural formula as Lewis structure. Okay, so this is an example. This is what we call as condensed structure. Yeah, condensed maksudnya macam susu pekat lah, condensed milk kan, so dia dipekatkan, it has been simplified and concentrated. Okay, kalau molecular formula biasa ni straight saja, tapi condensed formula ni it's been shortened. So for example, you have ethane there. So okay, so the numbering yang pertama tu sedikit lari sedikit lari, but you see when you have CH3 like that, the condensed will be CH3 sahaja. Okay, but if you have something like that, the condensed structure is that one. Okay, you have you accumulate dalam satu carbon tu ada berapa hydrogen, macam tu ya. So, but if you have horizontal bonds between carbons, okay, they are not shown in condensed structure, tapi they ada vertical bonds added for clarity. Sometimes people also use something like this. Dia masukkan dalam bracket. Dia masukkan dalam bracket. Sometimes you will be shown like that. Okay. So kalau ditunjuk macam tu, it means that it is extra bond connecting to the carbon. Okay. Not extra bond lah. Maksudnya dia ada satu yang sitting above it. Alright. So kalau you ada this complicated structure, for example, this is ketone with alcohol. So condensed structure dia akan jadi macam tu lah. Okay, you have everything, CH2OH, CH2C double bond O, CH3. Yang ini yang terbaik lah untuk condensed structure, so you see everything. This is condensed structural formula. Okay, you have CH3, and then see, it now, instead of using structural, dia dah dipanggil Lewis structure. So mana-mana pun boleh, tetapi saya tak perlulah, kalau macam ada additional pair of electron, you write it down. So this is condensed structural formula for ethane. So ini sama saja, and then these are further examples. Alright. Okay, for the purpose of discussion lah, sekejap lagi saya nak you all buat. Okay, sekejap So after that, kalau this is my favorite structure, line angle or skeletal structure. Biasanya perkataan ni adalah line angle atau skeletal lah, is the most simplified forms of drawings of organic compounds, where you will only show the bonds. Okay, you akan silentkan the carbon, okay, dan you akan buangkan the hydrogen. Okay, So macam contohnya case ini, okay. So essentially kalau begini, okay, the end part yang, okay, saya selalu cakap yang hujungnya ataupun bucu-bucunya adalah carbon. So ini adalah carbon, 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 carbon. Okay. Mula-mula orang nak buat line angle ni, usually dia orang buat macam ni dulu. Okay, I always tell my students apa yang you boleh buat. Nampak tak? Macam yang ini, this one is a butane straight chain. Tapi tiba-tiba jadi saya ingat macam ni. Apa yang you boleh buat mula-mula is, what you do is, draw like that, okay? But semuanya ada. You ada all the H's dah. Okay? Letakkan semua hydrogen dulu. Right? Put all your hydrogens in. After that, what you do? You akan bulatkan. Carbon ni jadi bulatkan dan hitamkan. Bulatkan dan hitamkan. Selepas itu, you padamkan you punya hydrogen. Selepas itu, you padamkan you punya hydrogen. Okay, padamkan you punya hydrogen. Okay, jangan padamkan the bond between carbon and carbon ya. So, you just padamkan the hydrogen punya chain bond dengan atom. Okay. And then, after that, you connectkan dia. Sambung balik antara ni dengan ni. Sambungkan elok-elok. So, let me, I kena padamkan dululah. This one. Okay. Alright. Okay. Sambungkan semua. You dapatlah last sekali this structure. You betulkan you punya yang bulat tu. So, for this purpose, okay, for example, ni ada example of line angle drawing lah. Okay, so untuk yang ini, apa yang saya nak you all buat sekarang, ambil an A4 paper. Okay, semua orang ambil A4 paper. Semua orang ambil A4 paper, saya nak you all buat ni. Saya nak you all drawkan saya begini. Buat dalam 3 column, and then you ada condense. Okay, and then you ada, saya rasa untuk mula-mula pelajar yang baru belajar, it's better untuk you buat structural lah. Structural. Okay, condense. And then line angle. Saya nak you all buat ni from methane to decane. From methane to decane. From carbon 1 to carbon 10. Okay, buat structural dengan condense dengan line angle. So, untuk, for example, I'll show you methane. For example, this is not structural, this is condense. Okay, saya nak semua orang buat ambil A4 paper buat. Sekarang saya bagi dalam masa. So, condense maksudnya begini, CH4. Okay, so dia punya structure begini. So, basically untuk line angle, you cannot use it for a single carbon. Tak boleh. Sebab dia tak ada connecting dots. Tak boleh. So, kalau for example, CH3 untuk ethane, boleh lah. Okay, so dia akan jadi begini. Dia punya line angle saja. Okay, so saya bagi masa you all dalam 5 minutes. Ada dulu-dulu pelajar diperlukan masa yang lebih. So, saya berikan in 5 minutes time macam tu. Buat daripada sekarang saya dah tunjuk example untuk satu carbon iaitu methane dan dua carbon iaitu ethane. So, saya nak you all buat begini dalam satu A4 paper. Okay, tak kisahlah line angle you ke atas ke bawah ke, condense structural macam mana. Ada pelajar, dia kata, doktor tak buatlah structure saya nak buat panjang macam tu untuk decane. You nak buat menegak tak ada masalah. You nak buat L shape pun tak ada masalah. Okay, janji semua hydrogen kena cukup, semua tangan carbon kena cukup. Boleh? Semua orang saya nak you all buat benda ni sekarang. Saya bagi masa 5 minit. Semua orang ada lagi ke? Sekejap, mana?
Ada.
Ada. Okay, kejap. Mana saya nak buka ni? Okay, semua orang buat sekejap. Macam mana nak? Ni. Nak tengok semua orang ni. Macam mana ni? Sekejap. Boleh kot. Boleh besar. So semua orang buat. If you have question atau you juga boleh share you punya screen Kalau siapa-siapa nak tunjukkan dia buat betul ke tak, you boleh share you punya screen pada saya. Okay. Siapa ada soalan atau nak tunjuk doktor betul ke tak, dia punya apa yang dia buat tu boleh tunjuk. Okay. Siapa yang macam tak confident ke, boleh ke macam ni? Boleh ke sengit? Boleh ke tegak? Apa-apa lah nak tanya, silakan. Okay, sebab yang kali ni je kita nak belajar drawing. Nanti minggu depan bila masuk structural chemistry dah tak belajar drawing. Lepas tu bila masuk alkane, saya akan terus, saya tak akan jump lagi kepada you punya structure, but terus saja kepada you punya naming, reaction and synthesis. Ada siapa-siapa nak tunjuk you punya screen? Saya nak ambil randomly boleh ke? Kalau anyone, siapa nak tunjukkan apa yang dia dah buat? Are you still there, you guys?
Yes.
Okay.
That's it, but we are not done yet.
Okay, buat dulu. Terima kasih.
Okay.
Okay, semua apa khabar? Dah okay ke? Siap dah ke? Daripada methane sampai dekin.
Belum lagi, doktor.
Okay. Sorry. Tanya je kalau macam ada yang stuck. Doktor tak tahulah sebenarnya nak buat macam mana ni. Tunjuk kat saya dan kita buat sama-sama. Okay. Ada yang dah siap ke? Yang nak tunjuk kat saya hasil dia boleh tak? Siapa-siapa? Volunteer? Ke saya nak saya petik nama? Naili, you dah siap ke Naili? Ni petikkan nama je
Belum, doktor. Doktor belum.
Belum. Okay. Siapa yang dah siap? Khairil, you dah siap ke? Saya petik je nama ni. Siapa yang dah siap?
Belum, doktor. Sikit lagi.
Okay. Sorry. Saya itulah tak tengok ni, saya tak tahu you all dah, kalau ada gambar boleh tengok tengah buat ke tidak. sorry terus
Okey, doktor.
sorry. Okay, so apa khabar semua? Anyone nak volunteer? Saya nak tengok seorang, dua volunteer. Babul, Aminah, are you done?
Belum doktor.
Okay. Siapa yang dah done boleh sebut ya, dia done. Nak share dengan kawan-kawan macam mana, ataupun siapa yang stuck, yang tak tahu nak buat kan. Tak apa, selamba je bagi tahu. Saya tolong. Tahu. Okay. Ada tak yang dah siap ke? Nurul Najihah ke? Nurul Najihah, you dah siap ke? Belum? Tak apalah, tunjuk setakat you dah siap. Najihah, you cakap apa tadi? Dek, alamak dia dah mute balik dah. Siapa ya? Siti Nur Atika. Tak kisahlah mana-mana, Atika Yusof ke, Atika Natasha ke. Dah siap? Tunjuk je setakat mana yang you dah siap.
Ya doktor.
Boleh tunjuk?
Saya dah siap tapi tak tahu lah betul ke tak.
Tak apa. Boleh je kita share dengan kawan-kawan semua.
Macam mana saya nak tunjuk?
Cuba share
Buat video.
You nak tunjuk kat video boleh. Share you punya content atau share multimedia. Ambil gambar ke. Saya jadikan you presenter lah. Mana Atika punya ni? Mana Atika? Mana saya nak buat Atika? Ni. Sekejap saya jadikan you. Atika cuba tunjuk ke bawah. Kawan-kawan nampak ke? Ataupun you, saya jadikan you presenter. Sekejap Mana saya nak jadikan you presenter ni? Ni. Okay, so you are presenting. Sharing will end if you change the presenter. Okay. So Atika, you are now presenter. Passing the presenter privilege to Atika. So Atika, you boleh share you punya tu tadi, tunjuk you punya gambar tadi. Saya nak tengok. Macam mana?
Tapi yang maintain saya tak sure doktor.
Kejap. Macam mana Sekejap. Saya nak tengok. Dekat balik. Naikkan balik. Okay, maintain memang tak ada. Maintain memang tak ada. Okay.
Tak ada kan doktor?
Tak ada. Sekejap. Atika boleh pen ke belakang sikit tak you punya kertas tu? Belakang sikit, saya tak nampak you punya structural formula. Memang dia tak apa nak jelas.
Nampak?
Okay. Untuk yang lain tu okay. Line angle pun nampak okay.
Structure.
So, you dah buat sampai decane lah tu. Tapi you punya carbon tu tak ada hidrogen tu, macam mana? You punya, saya tengok you punya pentane tu, contohnya, pentane you ada carbon 1, 2, 3, 4, 5. Dia ada tangan dia. Tapi tak ada hidrogen kan? Tak lengkap tu, Atika.
Saya tak sempat pun.
So, nanti kena lengkapkan dia mesti kena semua ada. Okay, dia kena semua ada. Okay. Macam mana saya nak?
Saya nak buat lagi.
Okay. So saya dah tengok example Atika.
Okay.
Thank you. So macam mana saya nak jadikan saya present?
Okay.
Thank you. Okay. So you all nampak my screen balik tak? Kejap saya cuba. Okay. So you all nampak my screen balik tak?
Nampak.
Alright. So, okay, very good. Terima kasih Atika sebab you volunteer untuk jadi apa yang nak cakap ni? Volunteer untuk menjadi kita punya example. So, most important dalam cerita ini adalah you kena ada 3 kolom itu. So, you kena make sure all your carbons are there. In addition to that, untuk structural, kadang-kadang pelajar dia terus buat carbon macam example Atika ni. Saya percaya dalam 30 pelajar saya hari ni, mesti ada dalam kalangan you all yang buat perkara yang sama. So, carbon tidak boleh, bila you kosongkan dia, carbon tidak pegang apa-apa, so structure itu belum lengkap. The structure is not completed yet. So, what you have to do is you have to make sure every branch, okay, of your carbons, of your compound must be ada hujung dia. Kalau you buat structural, sebab tu yang paling senang adalah line angle. Bila you buat line angle kan, you terlupa nak letak hydrogen. Tak ada masalah. Sebab line angle memang kita buang hydrogen dia. Tetapi kalau line angle tu contohnya you ada 4 carbon. Tiba-tiba you buat line angle tu 3 je. Tak boleh lah. Ataupun dia ada OH. So kalau OH ni you kena spell out dia OH. Okay, so tapi kalau structural, you kena make sure semua ada. Itulah yang paling complicated punya struktur adalah structural sebenarnya. Tetapi untuk beginners atau untuk you all nak recap balik, is the easiest among the easiest ones. Okay, for example, I'll show you. This is an example, a good one. So line angle, okay. Line angle drawing. For example, this one is 1, 2, 3, ada 6. So this one is hexanal. Hexanal is another functional group. So the numbering is wrong juga sebab you have to start daripada hujung sebenarnya. Okay, jangan percayakan dia punya numbering ni. So this one is supposed to be 1, this one supposed to be 2, 3, 4, 5. Numbering mesti dekat carbon with the functional groups. Sama macam ini ya. So tak payah tengok number dia. Yang penting you kena tengok macam mana dia jadi line angle. Okay. So kalau you tengok kat sini, dia spell out double bond O tu. Tetapi dia delete kan the hydrogen yang lain. So important kat sini, kalau you buat tadi, saya minta you buat yang paling ringkas dan paling basic. Maksudnya dia punya rantaian saja. Saya buat daripada carbon 1 kepada carbon 10. So carbon 10 tu kena make sure cukup berapa hydrogen. So ada 10 carbon, so hydrogen dia mesti berapa? 2n plus 2 lah. Kena ada 22 hydrogens. Ataupun senang sekali, you just buat drawings je. Make sure the drawings is completed. Okay. So this is further examples. Example of hexane, example of hex 2-in. 2-in meaning the double bond is located at carbon 2. Okay. Kalau example alcohol. Okay, alkohol you kena tunjukkan yang sekarang ada branch baru, ada ranting baru yang bersambung kepada OH. Okay, dan it's not only limited to straight chain punya compound. It's not only limited to straight chain. Straight chain maksudnya begini, but it can also exist for ring. Okay, even more appreciative, lagi sangat dihargai bila ring. Sebab you no longer have to put all the complicated condensed formula in, right? So for example, you have cyclo 2 in hex 1 on ni cyclohexanone punya derivatives, so all these are, that's why saya kata line angle lah favorite saya. Maksudnya line angle tu kalau saya nak buat reaction lagi senang nak berlaku. For example, reaction of the alcohol tu, I can simply change that into alkyl halide. I can change that into carboxylic acid, for example. Okay? So, you kena, kalau yang belum habis, saya tahu dalam ada 30 pelajar ni, mesti ada yang tak habis lagi. Kalau belum habis, cuba habiskan daripada methane sampai decane. Kat situ, you dah revise apa? You dah revise tentang number. Kalau lagi cantik, tulislah nama dia dekat tepi. Tambahkan satu lagi ruang kecil kat tepi tu, letakkan nama daripada methane kepada decane. Kat situ, you boleh tahu dah, okay, dec meaning 10 carbon. So, katalah saya buat OH kat hujung tu, gantikan you punya hydrogen, you boleh jadi decanol. Right? Okay? So, familiarize with that. Again, completekan, habiskan. Sebab saya ni buat begini online, itulah dia punya disadvantage dia, because I couldn't see. Kalau you all in my lecture hall, what I would do is I would go to every table and ensure everybody has actually completekan. Kalau dalam ini, mungkin ada yang you all baru buat methane aja. Ataupun mungkin ada yang tak buat langsung. Jadi, you kena bertanggungjawab pada diri sendirilah. Sebab kalau you gagal untuk buat yang the basic ini, nanti dia akan lagi deteriorate. Apa orang kata, dia akan jeopardize yang seterusnya lah. Okay, so methane kepada decane, make sure everything is there. Carbon, tak boleh ada branch yang kosong. Rantingnya mesti bergabung dengan atom apa. Alright, sama juga dengan line angle. Make sure setiap macam hexane ni, make sure hujung dia ada satu. So, ada satu carbon, 2, 3, 4, 5, 6. So, make sure everything is there. Katalah, ada yang kata saya, doktor, boleh ke kalau macam dia, hexane tu kan tapi dia macam ni. Macam ni, lepas tu tiba-tiba macam ni. 1, 2, 3, 4, 5, 6. Masih 6 kan doktor? Tak ada masalah. Tak ada masalah. Tak ada masalah. Okay, janji semua ada cukup karbonnya. Okay, boleh? So sebab you all boleh, so sekarang ni sebenarnya sampai itu aja, tapi saya nak tunjuk you all exercise. Semua boleh ke? Of course, untuk online punya classes, ideally kan, kalau if I'm not mistaken, 1 hour tu equivalent to 7 minutes je pun kalau live. Tapi sebab kita nak utilize betul-betul, so saya takkan complete 2 hours lah. Okay, saya akan jumpa you all online ini, and then saya nak bagi exercise ini untuk you all buat. Okay, so this is the exercise that I'm going to give you. I don't know whether you see this. Nampak ke yang ini?
Nampak.
Nampak doktor.
I don't know whether you like this or not, tetapi okay, remember untuk you punya assessment, saya tak assess you all untuk tutorial kan. Okay, so there will be no tutorial, tapi saya believe kalau ada exercise, it will be helpful untuk you all lah. Okay, so that's why saya nak buat exercise ini. Semua balik salin soalan ini. Salin soalan yang pertama, saya ada 2 soalan saja. Was it 3? Yeah. I have 3 questions here. I don't know whether we want to discuss it now or we want to discuss it in the follow-up class. Nanti bagikan pandangan you all macam mana? Atau saya nak tunggu you all buat sambil-sambil tu ke macam mana? Sebab boleh tak bagi pandangan you all? Saya buat 3 soalan ni. Okay, boleh tak bagi pandangan you all rasa macam mana? Anyone has opinion? Do you want to copy semua soalan? Lepas tu buat dulu, lepas tu macam mana? Ataupun saya tunggu you all buat, atau macam dalam 5 minit, 10 minit macam tu, and then kita discuss bersama ke macam mana? Boleh tak bagi pandangan you all? Anyone boleh? Norman, class rep, boleh tak bagi pandangan you?
Okay, okay. Dia,
Apa dia?
saya rasa buat dulu. Maksudnya, satu lagi 5 minit macam kita terus move.
So maksudnya buat live lah. Maksudnya saya
buat live.
buat lah.
Ah.
Okay. Sekejap alright. Kalau macam tu, saya bagi you all dalam saya tunjukkan soalan-soalan dulu. Sekejap okay. So saya tunjukkan soalan dulu. Soalan 1 dah tengok ke? Dah salin ke? Salin dulu soalan boleh? Dah ke? Soalan 1?
Ya, doktor.
Dah.
Okay. Soalan 2. Soalan 2 dengan 3. Salin soalan 2 dengan 3. Kalau dah, bagi tahu. Recording lah. Okay. So, let's go back to the topic tadi tu kan. Sekejap I have to show this in the record. So, it goes like that. So, ada SP2. We miss out on the ni because I paused dia punya recording tadi ya. So, macam tu. And then untuk 2B, you have CH2 and Cl. So, what you do ialah you akan you have to draw the structural formula, and then straightforwardly you akan dapat CH2Cl. So, dia ada CH2. So, ada hydrogen, Cl dan Cl. So, dia punya line angle dia a bit macam pelik sikit lah. It will be macam mana? Ada tak? Semua orang boleh buat ke yang Cl2 tu? So essentially dia tak boleh ada line angle pun. Okay. Dia just ada Cl. Dia very simple structural formula lah. Okay. So Cl, hydrogen. Macam tu saja ya untuk B. I should have better punya ni lah sebab line angle lah. Tapi condensed formula, based on the condensed formula ni lukis line angle ni. Untuk B tu sebenarnya tak boleh lukis lah. Okay. So maybe try untuk challenge yourself by having different structures and try untuk draw. Okay, now 3A, draw all possible resonant structures of the following molecules. So I padam yang lain-lain ni dulu. I erase everything else here. Alright. Okay, so alright. So the first one you have a double bond like that. And then you have CH2. And then you have CH. And then C double bond O. Remember, ada lone pair of electrons di situ. Dan di sini juga ada lone pair of electrons hydrogen. So many things that can be done here. First and foremost, remember oxygen is the most electronegative in this structure. So what you can do is you can move the double bond, the pair of electrons from the bond there. So I'll take this one, move there. Okay, remember arrow tu kena daripada yang dipindahkan. Okay, daripada situ kepada sana. So dia punya kepala dia you have to point the head of the arrow to which atom. Okay, so you akan dapat the first resonance shall be CH2 double bond CH and then CO, and then you have 3 pair of electrons negatively charged. Di sini ada positively charged carbon. Alright, and then next one. Okay, follow up to that, you can also use. Okay, now kita ada structure yang begini. So because you have now a new resonance form, untuk stabilize the positive charge carbon, you can move this pair of electron here. Okay, and then the next resonance you akan dapat CH2. Sorry, macam mana nak gerakkan ni? Okay, CH. Oh my gosh. Sekejap ya. So you will get, okay, So CH2 and then double bond there. Oh, CH. Okay, and then this one, and then oxygen ada 1, 2, 3, 4, 5, 6 negative. So now this oxygen is being positive. Okay, sebab dia dah donate kan, dia dah donate kan 1, and then this have now becomes double bond. Okay, and carbon yang positif tu sebab dia dah kurang, so you dah neutralkan dia, you dah tambahkan one pair of electron, so it becomes positive. Okay, in addition to that, selain dari pergerakan daripada oxygen side, you can also gerakkan daripada carbon punya side, because this carbon juga double bond. So in addition to dekat sini, you can movekan the double bond there, this one, these double bonds. Okay, try and do this, figure this out on your own, boleh juga So untuk B, you try untuk buat juga sendiri, but you have to remember there's a pair of electron there. So what you can do for B, let me take the pen and so struktur dia, okay, sorry, it's like that, and then okay, so saya akan tambahkan dia punya ni. Okay, alright, I'll add new slide. Okay, panjang kuliah kita hari ni so it's okay, we are near to the end. Alright, so you have something like that. Am I doing it right? I think oxygen, and then ada double bond, pair of electron there, and then positive. Saya rasa yang ni kena dekat sikit lah. Sekejap okay. Alright, so if you observe something like that, okay, electron kat sini, so what you do, firstly, you can move, ada positif, ada negatif, ada positif kat situ kan. You janganlah create positif yang baru. Do not create a new positive. Okay. What you do is, you have to neutralize that first. Ingat dalam satu compound tu tak boleh ada 2 positif. Tak boleh. It will be so unstable. Okay, for the purpose of discussion, yang macam tadi tu, bolehlah you gerakkan. So, this one, you can move that to there. You will observe the first resonance form here, where the double bond has moved to there, and then you ada oxygen, and sini dah jadi positively charged. Okay, dah jadi kurang. Dan that one, the positive charge yang awal tu, dah tak jadi positive. Alright, dia dah neutralize. So, you can also move this pair of electron there. Kan? So, dia akan jadi double bond kekal di situ because we are not moving it. However, this oxygen has become positively charged, and then you ada double bond dekat situ. Nampak tak 2 elektron tu dah hilang, dia jadi one bond tadi. Alright, itu sahaja untuk kelas saya. If you have any question, you can throw out your question now. So, is there any questions so far for residents? Is there any questions so far for residents?
Doctor.
Yeah, who's speaking? Theo, yes?
Yeah. Doctor, I want to ask, is it receive first and only you move the electron to the other atom, or it donate first and then receive?
Okay, let me give you an example, which is, not preferable at all, because essentially you have 2 atoms at the very same time, 2 atoms with negative charge. So you have to solve whatever problem that you have first. If there's extra, you have to donate them. If it's less, for example, in this case, okay, it's positive, then you have to do something to make it neutral. Did I answer your question? So let me give you an example. For example, okay, I'll go backward. Okay, for example, I have, let me draw another, okay. So, for example, I have this in question, okay? In addition to that, I have, for example, I have C triple bond N, something like that. Is it right if I want to move this one first? For example, this is my ridiculous example, see? So if I do that, then I will get whatever here, and then I will get something like that. Perhaps this will be negatively charged. This is a ridiculous example, but you are creating a new problem. Okay, you are creating a new problem. So Theo, it's based on what is your first compound that has been shown. If it's neutral, then you more or less you can move whatever electrons that you observe or whatever bond, and you will parallelly create a positively charged atom and a negatively charged atom. However, if you've been given a compound with existing charge, then you have to solve that charge first. Did I answer your question correctly, Theo?
Yes, doctor.
Okay.
Understand already. So
Long
means that have
explanation
to
kan?
make sure that
Mm-hmm.
have to make sure that the existing atom neutral first, only will move to
Yeah.
the other one.
Exactly. If you have negatively charged, then you have to solve that problem first. Donate something first. You cannot have a compound with two negatively charged atom, for example. It will so be unstable. Okay? Thank you.
Okay,
Any more
doctor. Thank
questions?
you.
Thank you. Any more? Apa dia, Syamina? You tanya apa tadi?
Doktor,
Aha.
yang kan kalau garis yang untuk OH tu kalau saya buat tegak tak apa ke?
Garis
Kan
OH.
macam doktor kan dia. Kejap.
Ha.
Okay. Dah nampak tak doktor?
Ha. Mana? Belum
Ni.
lagi.
Hello.
Nanti dia. Oh, tak boleh. Sebab kalau you buat macam ni, 1, 2. Okay, saya faham dah. You buat, sekejap saya draw sekejap. You buat adalah macam mana? Okay, more or less begitu. So if you are drawing it like that, so I'm going to show what you are actually doing. This is the same thing, right? So it's fine. It's the same thing. Yeah, it's fine. Okay? Sama kan macam you buat tadi?
Doctor, I think she drew the OH straight from O double bond O there.
Like this, is it? Like this
I think so.
Kan? But I think that will be okay. If I tengok ni sama je. So that's fine. Sebab you are not adding any carbon. Yeah, and all your carbon are still there. So it's 1, 2 carbon. So 1, 2 carbon. 1, 2 carbon. How many carbons do we need? We need 1 and 2 carbon. So that's fine. It's strange, a bit strange, but that's fine. Okay, so we'll move. How many carbons do we need? We need 1 and 2 carbons. So that's fine. It's strange, a bit strange, but that's fine. Okay. If there's no question, I will end the session. Okay. Ada question?
Tak ada.
Alright. So tak ada. So kalau tak ada, saya akan jumpa you all next week. Okay, saya akan jumpa you all next week. Yeah. Alright. So thank you so much, everybody. Okay. So bye bye, everyone. So I'm going to do I stop sharing? Somebody has left already. So macam mana nak stop sharing? Stop sharing. Okay. Bye everybody. I'll see you all next week. If you have any question, throw me out the question. Hopefully before the end of this week, week 3 punya notes will be there, including everything lah. Sekarang belum siap lagi. So okay. So bye everyone. Thank you.
Thank you, doktor. Bye-bye.
Bye bye. Bye.